All right, everyone, welcome to our part 2 of our 3-part series here with Prolific and Red Hat. We've got Sandeep Chalingi, who's going to be our fearless leader for the afternoon again today. Sandeep is a solution architect in our integration department and is really our Red Hat in-house guru, if you will. So without further ado, Sandeep, I'm going to hand the reins over to you.
Thank you, Suzanne. Thank you, Pam. Hello, everyone. Good morning, good afternoon, and good evening from whichever part of the world you have connected listening. Welcome to Prolific's second webinar session on Red Hat Openshift. My name is Sandeep Chalingi, and I head up platforms and DevOps practice at Prolific, primarily working with our customers in their cloud adoption and cloud transformation DevOps adoption journeys. So in our last session, we discussed about modernization of legacy applications, building cloud native applications, and how Openshift platform will allow the next generation applications to move to market much more quicker and allow organizations to build highly available, scalable, resilient, auto-healing, and cloud native supporting platform for developers and platform engineers. So in this webinar, we'll be talking about Openshift pipelines with Tekton. As engineers and architects and technologists, our job is to make sure Kubernetes or Openshift development experience is much more easy. And Red Hat Openshift has ensured the developer experience is clean and easy by embedding the right tools to ensure cloud native development is easily adoptable and scalable for applications in this new platform. So in this today's session, we'll be covering cloud native and DevOps, automation pipelines, and Openshift pipelines with Tekton, which will be followed up with the Openshift Tekton demo. So before we dive into the core concepts about OpenShift and OpenShift pipelines and the OpenShift build strategies, I'll quickly talk about the CI/CD aspect of it. So continuous integration, continuous delivery, and continuous deployment pipeline is the core of DevOps. It allows us to identify defects early, and it will allow us to shift left on testing. With less effort, we can deliver faster, ensure better quality with less risk. CI/CD is an evolution of value where continuous integration automates us all the way to have build some automation regressing testing and later building a package image where you will going to be deploying the package image into an actual runtime. With continuous delivery, it will automate us all the way to having something we think is ready to be deployed to various different environments. It could be dev environment, it could be QA production. The next one is continuous deployment. This provides us with all the right quality checks, the automated quality checks, and the automation which will allow you to do the continuous deployment into all the environments. So to make this relevant, let's discuss about how do we implement CI/CD with the type of tool chains. So, for example, in an environment, a developer environment contains a number of open source tools that will be installed and configured in a cluster that will be the foundation for the developing a cloud native applications and deploying them to any kind of Kubernetes environment or OpenShift environment. So in this tool chain, the flow is going to be where a developer is going to be checking in the code into a source code repository, and the developer persona can pull or push the code to which it will trigger the pipeline, which kind of performs the code analysis, where the continuous integration kind of branches out. It provides the code analysis. It does the building of code artifacts, packaging the artifacts into container images, and then pushing those images into an artifact tree or an image registry for deployment to multiple runtimes, so that you can actually see the code from a developer workstation to Git and through an actual runtime. So these are the type of tool chains you would be using from a deployment standpoint. So the next topic would be is automation pipelines. Pipelines is a very important aspect of software development, which allows in implementing continuous integration and continuous deployment process. So this process automation consists about a repeatable process for software and artifacts being built and deployed in the CI/CD process. So there are several pipeline steps like building and compiling code, running unit tests, code analysis, security, and installing it, right? It's also not one size which fits all to each of the organization, because each organization might be in a different landscape of specific tools, or each business unit might be in a different journey within their DevOps adoption. So one of the key things what I want to address here is the automation is going to be very, very key. And the idea of pipelines is the CI/CD pipelines, it will automate these kind of sequence of tasks, like building a code or committing a specific code, testing it, deploying it, and monitoring it, where the continuous automation pipeline will show that value flowing through it, which will reduce the cycle time and improve the code quality, as well as reducing your operational investment. So this is a virtuous cycle of continuous integration where developers commit the code into the SCM, and the continuous integration server fetches all of the latest builds, runs the tests. Yeah, and let's say, for example, the test actually failed, it most importantly kind of notifies us. So the pipelines is the most foundational aspect of CI/CD, where you'll do the same process repetitively so that you can get your code to runtime much more effectively. So while you set the right automation pipeline foundations, the developers will have more time to focus on the quality of code, where they'll be focusing on building better code, and the team will be focusing on major improvements, like the focus of the quality and focus of deployment itself. So this is all a journey itself. Again, there is value all the way along this journey. So a customer might be in any specific point of this journey. You could add things to this. You can remove things based on your requirements. So containers plus Kubernetes is cloud native, and the core dimension of cloud native development is DevOps adoption. As we decompose the applications and software components into microservices in containers, the dynamic orchestration, optimized manageability becomes the foundation to ensure it is successful. So we need to put this discipline in place where we use the right type of tool chains, ensure we are automating the deployments, testing practices, so that very less human intervention is done. This robust process will ensure the development and deployment lifecycle is much more repeatable every time and truly trusted, and ensuring that the code quality is at its peak, and making sure the feedback loop is continuously evolving, so you can see the right type of artifacts being deployed into runtimes, and you see very less impact going forward. In the microservices design, we design independent deployable units. So CI/CD pipeline reduces the risk with smaller release per microservices, and containers and container orchestration engines like Kubernetes, instead of building and deploying code, build and deploy container images, these specific CI/CD pipelines will automate and ensure that the building of the images and uploading the images into the container registry, where you're actually pulling the code from, where you're getting the code down, is fully automated, so that you see very less impact, and making sure the process is kind of repeatable. The last aspect of it is monitoring. What you can't see is you can't monitor. So the Kubernetes platform does provide, Kubernetes and OpenShift platform does provide the right monitoring features that will allow you to automate and minimize the risk where platform is actually seeing during a deployment. So let's say, for example, if you're having a rogue pod or a workload which is kind of spinning more, or getting deleted multiple number of times, you kind of have that visibility into that monitoring of the workload, where you can take decisions based on that specific aspect of it. So we have seen an explosion of these type of practices with cloud native development, with a very single goal to complete multiple iterative cycles, which will allow us to quickly get high quality with no downtime at all. The newer standards are not downtime, but the newer standards are having less latency itself. So with this explosion of these type of practices, where you see from a development perspective, you'll be primarily be focusing on designing your code, planning your code, building your code, testing it out, starting with agile planning, structural of microservices, continuous integration, and infrastructure as a code, automatic builds, and producing containers, and making sure all of the development is kind of shifting left towards the testing itself. From an operational perspective focus, the operational focus is going to be more around how you can do the release, how you can do the deploy, how you can operate it, how you can test it out. So bringing these two features together is going to be very, very key to ensure the success of DevOps. So OpenShift platform provides support for the entire lifecycle of your application. So let's do a quick recap of OpenShift itself before we go into OpenShift pipelines. So OpenShift platform is leveraged to manage containers, and OpenShift is very cloud agnostic, where you can deploy it anywhere on the cloud, or it could be deployed on-prem. It abstracts away the underlying hardware like computing, networking, and storage by providing the enterprise-grade Kubernetes. And it also provides complementing cluster services like networking, HA proxy, which is provided totally out of the box. It also provides developer accelerator services to provide seamless experience. And it also cleanly stitches platform services like CI/CD Kubernetes native pipelines. And it gives us access to next-gen applications, application catalogs to support AI, ML, or cross-automation, or data analytics, or integration type of workloads that you can deploy into OpenShift runtime, which will make the developer experience much more easy. So you can configure OpenShift to build and deploy cloud-native apps and services as it handles all of the orchestration from a pod lifecycle standpoint, where the orchestration of it is managed from the master node control plane. So this is the bare foundation of OpenShift platform, and the advanced cluster management is a new feature which was released within version 4.4 and 4.5. Is a new feature of OpenShift. It provides kind of the end-to-end visibility, and which will provide you the flexibility to control your Kubernetes clusters. And the Kubernetes clusters can be either on-prem, it could be on multiple clouds, but you have the visibility or flexibility to control multiple Kubernetes clusters from a single pane of glass. It also provides built-in security policies that you can enforce on multiple clusters, and you can manage these clusters by enforcing these type of policies where you can scale them, where you can reduce them as well. So these are the new features that are part of OpenShift platform. Having discussed about the OpenShift foundation, I want to talk about how OpenShift has evolved in terms of deploying the images into its runtime. So OpenShift pipelines is not new. So OpenShift pipelines have been evolving, from version 3 to version 4. So you used to have the build strategy. So we'll talk about a couple of build strategies before we pivot into the OpenShift pipelines and OpenShift Tekton. Build is a strategy which is used to transform source code into a container image. There are multiple build strategies which are done. A couple of the examples are source to image, build pipelines. You can do it with Docker. You could build custom build strategies as well. Developers kind of write their code using the existing development tools such as Maven or Dockerfile and even on Git, right? And then get the access from the OpenShift web UI and or the CLI to create that application from the code, right? So the source to image is a tool for building reproducible Docker formatted container images. So it produces ready to run images by injecting application source into a container image and assembling a new image. So this new image kind of has the base foundational image, which is called the builder, and the source code, which is ready to be run using the Docker run command itself. So the source to image is a combinational code with build image and stores the resulting application image in the image registry itself. So you're seeing the life cycle of a developer persona where it is uploading the code into Git repository, and then the build image is getting the foundational base image and injecting that code into the build image and creating an image, a new image. This new image will be fed into the image registry on the OpenShift, and you can also push this image or new image into an external source repository as well. Like Docker Hub or Artifactory or Amazon ECR as well, where OpenShift kind of monitors these build images. Whenever there is new build images being done, it is going to identify it and deploy that image into actual runtime. So all of that control of build strategy is done by OpenShift, and it does that deployment into the pods on the worker nodes. So these type of workloads could be any type of workloads like JBoss or Java applications or Tomcat applications or any kind of web server applications that you want to deploy into Kubernetes runtime or OpenShift runtime. The next build strategy what we're going to talk about is pipeline builds. This has been very popular in version 3.11, and if you are OpenShift customer today, I'm sure you have already have implemented build pipeline strategy. So build pipeline strategy is used to implement mature flows like continuous mature flows for CI/CD. So within this pipeline, all this pipeline does is an automation of a series of tasks in multiple stages. So on the right side, what you're seeing is a Jenkins file which has various different stages, and within each stage you have a series of steps that will be executed, and it could be running a Maven package from a Git URL, or you're building a custom image and feeding that custom image into OpenShift pipeline itself. In this specific use case where developers have to write the code to define how the pipeline will operate, and based on that, the Jenkins files, and this will be done using Jenkins file. The developers might be using different Jenkins files based on the different environments what they're actually being testing on. It could be dev environment or production or testing, where developers will kind of store their code in Git repository, and Jenkins will access the latest code from the Git repository to run the pipeline. So In this structure, what you typically used to do is, create a Git repository for the inventory source code. You would push the inventory source code to the Git repository, define the deployment pipelines as a Jenkins file, what you're seeing on the right side, and using OpenShift pipeline, you would create it using the specific Jenkins file. So what this allows is, whenever there is any kind of code commit on Git, that would automatically trigger this build pipelines. And using this build pipelines strategy, the pipelines would either download the image, create a new image, and then deploy the image. So this process would need an actual Jenkins server, which is auto provisioned, and it does it using Jenkins that will be deployed in a specific namespace. So the newer approach is going to be slightly different than Jenkins, which will be more around Tekton itself. So before I go into Tekton, I want to talk about OpenShift pipeline operator itself. So before we talk about OpenShift pipeline operator, which is Tekton, we want to talk about what is an operator, right? So you can deploy complex stateful applications and manually deploy a lot of these applications using Helm charts for the first time. But what happens when you deploy these applications is it kind of becomes a little bit difficult to manage its upgrades, managing its patches, and making sure its life cycle is actually good. So these operators kind of represent the equivalent of what human operations that we do. And these human operations are kind of converted into a knowledgeable base for what the operator is going to take actions on. So the operator concept itself is a maturing concept where the operator lifecycle can vary from multiple different features. It has 5 different type of features where it could go from doing an actual installation itself and solely run in an autopilot mode completely. So so the operators can work and control resources like pods. They can also control routes and config maps and builds where the controllers are doing the deployments of actual replica sets and deployment configs. So operators are definitely the future because they allow you to manage and deploy applications, which is done using a custom resource that is created, and this custom resource observes the current state and analyzes the current state and makes sure what the desired state is, and it acts to meet the desired state by deploying the application. It could be scaling up of pods, it could be scaling down of pods. Operators are packages, are packaged as images and run as pods. So when we do the demo of the OpenShift pipeline operator, which is Tekton, we'll discuss a little bit more on how each of this custom resource definition is going to be a single pod, and how the individual steps will be different containers within it. So the operator's maturity range can vary from basic app install to provisioning and making sure we're doing configuration mapping, to seamless patch updates and full application lifecycle management itself. So application lifecycle management could be backing up a specific application, or during a specific failure, how do you do automated recovery? How do you get deep insights of the metrics that are generated by the application itself and generate auto alerts? And based on these alerts, you would take decisions like, if I have to increase the number of pods, if I have to decrease the number of pods, or should I be scaling it into a different availability zone or whatever it is, right? So as the maturity of the operator kind of increases, it becomes more self-sufficient, more driven, auto-driven itself. And that mode is called autopilot mode. So the core topic of the hour today is OpenShift pipeline operator, and OpenShift pipeline operator is is based on Tekton. So OpenShift pipelines have been through a transformation journey in the Kubernetes style CI/CD builds, and these builds are based on Tekton, and these builds provide CI/CD experience through a tight integration with OpenShift and Red Hat developer tools as well. The OpenShift pipelines are designed to run each step of the CI/CD pipelines in its own container, allowing each step to scale independently to meet the demands of the pipeline. The Tekton runs as a serverless, which means that's full control on pipelines and plugins and access controls with no CI/CD server to manage it. It has a full integration CI/CD experience where a developer can have seamless experience, with Red Hat tools like VS Code integration with Tekton, or any kind of other tools that you want to integrate with Tekton. So it has all of this very seamless integration experience that you can do out of the box with OpenShift Pipeline Operator. So the OpenShift pipelines are the standard CI/CD pipeline definitions that are easy to extend and integrate with your existing Kubernetes tools. So you can build a pipeline on Kubernetes and extend that out to any other different type of Kubernetes on a different Kubernetes offering. So it is very easy to port from one Kubernetes implementation to a different Kubernetes implementation. So in the specific Tekton pipelines, the OpenShift pipelines will be using OpenShift pipelines to build images with Kubernetes tools such as source to image, Builder or build packs, and in our demo we'll be using Builder and source to image to build a specific build image. And the OpenShift pipelines operator gives us the flexibility to view the pipelines at a specific namespace level and also at a cluster-wide level as well. So when we install this OpenShift pipeline operator, you can select if you want to deploy to a specific namespace or you want to deploy to individual namespace as well. So that's the out-of-the-box features which the Tekton pipeline operator provides you. So before we go into the demo, I want to give a foundational overview of what is there on the Tekton. So you can use the Tekton, you can use the OpenShift platform developer console to create Tekton resources, where you can view the logs of the pipelines, a pipeline runs, and it will allow you to manage pipelines in your OpenShift container platform namespaces. So the Tekton is implemented using custom resource definition, which are called CRDs, and it is a way of building blocks on top of Kubernetes itself. So Kubernetes by default comes with resources like pods and deployment services or routes or services, right? So essentially with Tekton, we're building custom resource definitions where we can create these custom CRDs, and you can create binaries that would take actions on those resources itself. So you can write custom resource definitions to take actions on pods or any other type of resources. So a step is the basic Kubernetes container spec, where you can define a container image. The information you want to run, like an image volume or a specific environment variable that you want to feed in, what variables and arguments you wanted to pass, those are all defined in the step itself. A task is another type of CRD, the new CRD, which will allow you to combine a series of steps, and these steps are a sequence steps which are run in a sequential order that are running in OpenShift or Kubernetes itself. The next CRD, what we're going to talk about is pipelines. The pipelines will allow you to combine multiple different tasks, and these tasks can run either sequentially, or it can be run, concurrently, or it can be run in a, any kind of mind map that you want to decide how your pipeline has to execute. It could be executed based on, if a specific task is going to take a set of 2 seconds or 3 seconds, then maybe you could align these steps in such a way that they can complete the order without waiting on a different task. So you can design your pipeline in such a way based on the time the tasks would actually take to complete. So pipeline gives you that flexibility to design tasks either sequentially or concurrently, or any kind of fashion you want. So you can execute these tasks on multiple nodes and take inputs from multiple nodes or one single task and feed them as an input to other tasks as well. That is the kind of flexibility that these tasks provide you. So we talked about tasks, we talked about pipelines. So these are the CRDs which you create once, and then you can use them over and over again. So the use of Tekton, the definition of tasks and definition of pipelines are designed in such a way that they're very agnostic. You're not going to give a specific Git URL or a specific parameter on these tasks or pipelines, because you want to make it more agnostic, that you want to reuse these tasks over and over again. And also you would need to execute these pipelines and tasks. So for you to execute these pipelines and tasks, you create a pipeline run and task run, which will provide the right inputs like parameters and images and Git URLs, so that these actual tasks and task pipelines would be executed. So these are the type of definitions what we'll be creating within the Openshift Tekton demo. There are other types of CRDs as well, which we'll be creating part of the demo, which are build trigger binds and trigger templates and event listeners. So these last three trigger templates and event listeners are used to detect any kind of Git changes, and that Git changes is hooked using a webhook, and that is going to trigger an event using the event listener and generate a new pipeline automatically, so that you don't have to manually trigger it. So the initial first 5 steps, you can initiate it manually, but also when you build a trigger binding and trigger template, the event listener is going to listen for any kind of Git commits, and it is going to trigger a pipeline run. So in total, we have discussed 5 to 8 custom resource definitions. A step is an individual command to execute, and a task comprised of multiple sequence of steps, and a step represents a discrete and a self-contained part of a process. An ordered step of task is called a Tekton pipeline itself. So on the left side, what you're seeing, it is called the Tekton pipeline. The Tekton pipeline run can instantiate and manage pipelines and pods in the Openshift cluster. The pipeline run and the task run will allow you to execute the required information, what needs to go into the actual runtime. So when the Tekton pipeline can instantiate and manage pipelines and the pods in the Openshift cluster, the pipeline runs and the task run to execute. You need that very specific important information, like the image registry information or the Git repository information. When you provide that kind of information from the pipeline resource, the pipeline runs are going to take those information, and they're going to create a new pod using the Tekton controller itself. And the Tekton controller is stored in the managed in the managed node from the control plane itself. So this is a very high-level architecture of how the Tekton looks like, where the developers can actually interact with Openshift to create these individual steps, tasks, pipelines that are stored within these are all stored within the Openshift etcd itself, which is in the managed nodes. When a developer wants to run them, they can create pipeline runs, and the task runs, those are picked up by the Tekton controller, which interacts with the managed node, and all the pipeline tasks and steps that are related to it are executed based on the sequence of steps which are within the individual tasks itself. And when each of these tasks are created, an individual pod is created, and each individual step are run within its own container itself. So when we do the demo today, we'll look at the individual pods that have been created and individual containers that are created within a single pod. The webhooks can trigger Tekton pipelines, like building a new image, running tests, pushing new images into image registry, and deploying a new image to multiple different namespaces based on your OpenShift cluster environment itself. So this is the demo architecture of what we'll be showing in the demo today. So part of the demo, what we'll do is we'll create a pipeline that is going to take the source code of the application from GitHub, and then that is going to deploy it onto OpenShift. We'll be deploying two types of applications. The first application is going to be a backend application, and the second application is a front-end application where the backend application clones the source code from the Git repository, and then it builds a container image using Builder. Builder is a cluster task, which is out of the box available by Tekton, and the application image is then again pushed into image registry, from where the deployment is actually going to happen. So very similarly, the backend application or the front-end application is also going to be getting the source code from a backend application, build it using Builder, and the image is going to be pushed into the image streams, and then we'll be doing the deployment of the image into OpenShift runtime. What you've also noticed here is there are no references to any kind of Git repositories or any kind of Git URLs or Git repository or image registry. So all of that information will be pushed within the pipeline itself, so that this pipeline is going to be very agnostic, where you can reuse it across multiple environments and stage through the application multiple different life cycles itself. The pipeline allows you to abstract away those type of Git and Git source repository information or the image repository information, so that all of those information are produced by the pipeline resources. So I understand that I'm throwing a lot of jargon about pipeline resources, pipeline runs, and pipeline and tasks and steps. But as we go through the demo, you will see how each of these custom resource definitions are designed in Kubernetes that will allow you to manage a CI/CD pipeline. So we've discussed until the pipeline run right now. The next important topic is how do you trigger it when a Git commit is actually happening, right? So on the right side here, when you build a pipeline run, you can initiate this build pipeline run manually itself. You can go into Tekton and do a drop down on a couple of options, and it will create the pipeline for you automatically. But the event listener pod and the trigger binding and trigger template are the additional custom resource definitions that we need to create that will allow the the commits on Git repository to trigger those events, and these trigger templates will internally trigger the existing pipelines and deploy the same workload onto Kubernetes or OpenShift. So a trigger template is a custom resource which has parameters that can be substituted anywhere within the resource of a specific template. So the trigger template is going to be much more parameterized, where you can substitute all of these values, and all of those values substitutions are provided by the trigger binding itself. So the trigger binding is a map which will enable you to capture all of those fields that will be fed into the trigger template, and the event listener is the one which combines the events which are generated by the trigger bindings and the trigger template to generate a new event that is going to execute a pipeline run. And once the pipeline run is executed, it is going to do a deployment into the OpenShift runtime. So the event listener pod, or the event trigger binding, is not just a single namespace a scope. It can be designed to reflect at a cluster level as well. So the component is not going to be just for a single namespace. Having discussed about the Tekton demo architecture, what I would like to do is quickly switch over to the demo aspect itself. To give a quick overview, this demo is on IBM Cloud, and I have OpenShift cluster deployed on IBM Cloud. And I'm just going to quickly start up my web OpenShift console, and it's going to open up the OpenShift console. Okay, this is my OpenShift console. I'd like to see what existing workloads that I have, and I've already seen a couple of workloads that are already deployed on the OpenShift console here. So part of the first operation, as I've discussed, is to create. My apologies, I think something is refreshing. Let it refresh. So this is the OpenShift dashboard. I'm sure everybody who has seen OpenShift version 4, the look and feel is kind of same. Version 3 is a little different when compared to version 4. The user experience and developer experience with version 4 is really good when compared to version 3.11. So before we dive into the OpenShift pipelines, the very first step on the OpenShift pipelines is to install the OpenShift operator itself. So I've already installed OpenShift pipelines operator. The OpenShift pipelines operator, gives you the Tekton implementation. So I've already installed OpenShift pipeline in my OpenShift cluster, and it's deployed across cluster wide itself. So how do you do a deployment of OpenShift pipeline is, go to the operator hub. The operator hub is where you can, find all of the catalog information about whatever is available from an operator standpoint, and just search for OpenShift. Oops, I think I was typing in the wrong location. Just search for OpenShift pipelines. Yep, OpenShift pipeline operator. So once you find this, you just have to install it and subscribe it. I've already installed it, so that I'm not gonna waste the time on installing the operator again. But once the operator is installed, you can find it under the install operators. It is already installed. The next step is to create tasks itself. So within the OpenShift environment, the OpenShift pipelines and the OpenShift pipeline runs, the OpenShift tasks and cluster tasks are the features which are available out of the box when you install the OpenShift pipeline operator. So these are the cluster tasks which are available out of the box. It provides you the cluster tasks like builder or source to image, what we have discussed in the previous slides. There are multiple different types of source to images, like source to image Java, PHP, .NET, or Python, or any of these type of source to image which is pre-configured. These tasks are available out of the box, but you can create custom tasks as well. So in this demo, we'll be creating some custom tasks, and I want to show you some quick tasks. So the quick tasks, we'll just do a quick overview of the tasks here. This is a task which will be called using a pipeline. And in this task, what you have is a single step. It only has one step, and it is getting the image. We're passing all the working directory and what are the type of commands and arguments that this specific step has to execute. So within this task, it is going to execute this single step, and this step is going to be executed within a single container. So I'm going to quickly go ahead and create a couple of tasks and see how those reflect on the OpenShift environment here. Before I connect to it, I just want to make sure I'm connected to my OpenShift console. I just have to download the token, ensure it is connected. I know this video is recorded, but I don't think you can use this token again because this token is kind of aligned to my user account. So I've connected to the OpenShift, which is deployed on IBM Cloud, and I'm going to execute some creation of tasks, and these creation of tasks will show me what tasks are available on the system. So as of right now, I'm doing a Tekton task list. There is no task list available on the Tekton right now. So as I create these individual tasks, we'll create multiple tasks that are going to be reflecting on the environment, on the OpenShift environment, which will be reflecting in the pipelines dashboard. So we'll do a quick validation about tasks. It just shows we've created a task called apply manifest and update deployment. These are the two tasks that will be called from a pipeline. And once this task has been created, you can see all the task list. You can also see the cluster task list as well. These are all the existing cluster tasks, is what I've shown in the dashboard earlier. So once this is done, our next step is to create an actual pipeline itself. So we'll do a quick walkthrough of the pipeline task to see how a pipeline is going to look like. So we just reviewed the task, and within the pipeline is again constitutes of series of tasks, as I've explained before. Within a single task, within a single pipeline, you can have multiple tasks. What you're seeing here is you have three tasks that are run in the pipeline. The first task name is called build image task, and it is executing the cluster task builder, which is out of the box, and that is going to be the first task itself. And then it is going to run the second task, which we have manually created. The task name is apply manifest, and it is going to run after the build. It is going to run after the build image first task. And we're creating a third task, update deployment, which we have custom defined CRD definition, which will run after the apply manifest. So this pipeline has a series of tasks which are run in the first task as build image, and the second task as apply manifest, and the third task as the update deployment itself. So with this task, when you send the right pipeline resource information in, it is going to define the image, and it's going to do a deployment of the image into the OpenShift registry. So let me just go ahead and quickly create the pipeline definition. So this is going to create a pipeline definition. So just created the pipeline definition. I can do a Tekton pipeline list to see if it is created or not, and it has created it. It was created 8 seconds ago. So So Tekton is command line as well, and you can view the same implementations on the the dashboard as well. So I'll just do a quick overview on the dashboard. So these are the two tasks what we've just created, and these are the pipelines what we've just created. So tasks are residing inside the pipeline. So when you open this pipeline, you'll see these tasks that will be called upon, right? And for these tasks to actually run, you need pipeline resources. So I've already pre-configured a couple of pipeline resources ahead of time. What I'm going to quickly do is go ahead and create a new pipeline resource, which will allow us to, go ahead and create a new image and do the deployment of the image. So while I start doing that, I am going to do that deployment, do the creation of the pipeline resource manually. So I'll have to, give in some key resource name. So I'm going to create a pipeline resource by name API image, and well, you can do it from here, or you can do it from the Tekton pipeline itself. I would like to choose it to do it from the Tekton pipeline dashboard itself. So the Tekton pipeline dashboard is a very similar view of the pipelines itself. All the components what you're going to see on the Openshift pipelines will be on the Tekton dashboard as well. So within the pipeline resources, I'm going to create a new custom resource definition for API image, and I'm going to be selecting the image namespace to be deployed under the pipelines tutorial, and this is going to be an type image because I'm creating a definition for image, and the URL would be the image registry URL where you want to feed the specific image itself. So once the image is built, this is where the image is going to go, be stored in the image streams. So we've just created a new custom resource definition. You could do it manually, or you could do it, from command line as well. I just choose to do it from here. We're also going to create a new custom resource definition for repo as well. And this repo is going to give us information about what Git repository URL we're going to be using within this deployment. So we'll have to quickly select the namespace name, and it will be our pipeline tutorials, and it is going to be Git because it is the API repository information. We need to provide the Git repository information, and I'm going to be providing the Git repository information where all the application information is stored over here. We'll also be providing the release version name. I'll just give a sample release version name as release tech preview 1, and do a quick create. So we've created two new custom resource definitions, and we'll use these custom resource definitions to generate a pipeline. Okay, so part of the next step is to go ahead and start a Tekton pipeline, and I'm going to do it via command line using this command, which will allow me to start a new pipeline. So I've just deployed it, and it says that the deployment is done. We can check it as well. So what you're seeing here is I've done a Tekton pipeline list. The deployment was done 4 minutes ago, but the build run is started just 11 seconds ago. So I want to just quickly switch over to the graphical view where I can see how the pipelines are actually running. So in here, when you executed a pipeline, you can clearly see the pipeline builds, and the pipeline builds. When you click on the pipeline builds, you can see in which specific task the implementation is at. Like we have 3 steps, 3 tasks within the pipeline, and within these 3 tasks, each task has its own internal steps as well, and each task has a build step and a push push step as well. As I've mentioned, each of these tasks have their each individual pods as well, right? So when you switch the view to pod view, you'll see that there are individual pods that are dynamically being created and terminated as well. So if you see all the completed pods list, you'll see all the pipelines that are being created and destroyed, because internally it is using all Kubernetes native resources to build the pipeline CRD components and the resulting artifacts that will be pushing it into the image stream itself. So I'll be switching the view back to pipelines view to see if the deployment was actually successful or not. So I'm seeing that build and deploy was actually successful. And it just happened, 2 minutes ago, and the duration was run for 1 minute and 10 seconds. You can also have a very deeper view from a log standpoint as well. Within each of these individual tasks, you can see what step has been run, right? Within the build image tasks, we had multiple steps, and the first step was for it to get it from this specific repository. So it was getting the source code from the repository, and then it was doing a build image using Builder. It has done the build image, and the other step for it was to push the image into the Openshift registry. So looks like it has pushed the registry, and we've built two custom tasks, which is the apply manifest and the upload deployment as well. So these two tasks are also both successful. Before I go ahead and see if the deployment is successful or not, I want to show you the image streams itself. So within the image streams, what you're going to see is the image streams for app UI, and I want to do a quick history of it. If you look at the history, just 2 minutes ago, there was a new commit being done to the image streams. So this was the latest image that will be used to be deployed into the Openshift runtime. While I am on this namespace, I'm just going to do a OC get pods to see what the deployment status was. So if you see, there was a recent deployment just 2 minutes ago, what we've done deployment of the application. While we have done the backend application deployment, I also want to do the front-end application deployment, which is more of the UI experience, where you'll see that the actual application has been deployed. So in this second deployment, what I would like to do is I would like to do the deployment from the Tekton pipeline dashboard itself. So quickly go to the Tekton pipeline dashboard and go to the pipeline runs. And in the pipeline runs, I can select what type of pipeline I want to run. I want to run a UI repo, and I'm going to use the UI image. And from a deployment standpoint, I want to use the deployment as vote UI, and everything else will be done defaultly. So these are the different types of ways that you can actually deploy pipelines, either from command line or from the Tekton dashboard or from the Openshift pipeline console itself. So these are different ways of building pipelines manually itself, right? But that is not what we want. We want the experience to be much more seamless, where if a developer kind of checks in or does any kind of code commits on the runtime environment itself, or on the Git, we want to trigger a specific build itself, right? So we'll be configuring. I've actually pre-configured the build triggers and trigger templates and event listener. All we have to do is just go onto the event listener or the Git and do a Git commit, which will generate a new pipeline, which is automated from the webhooks. So as you're seeing here, you're seeing that the web UI has been deployed. It is terminating an old pod because this is a new deployment which has been happening. Once the deployment, well, looks like the deployment is already ready, which means the deployment should have been successful. We can quickly switch over to the UI and see the history. You will see the history that a minute ago that a new image has been published into OpenShift image streams. And on the pipelines, we can do a quick pipeline run overview. You'll see 57 seconds ago, a build pipeline was actually successful. And in this, all the subsequent tasks are also successful. Good. So I want to quickly switch over to the other aspect, which is the Tekton trigger binds and Tekton event trigger bindings and trigger templates itself. So I'll do a quick list of Tekton trigger bindings, and you'll see what is available. You can do a Tekton help to identify what is available for you to run. Tekton trigger binding and list is going to give you if there's any existing trigger binding that has been available. So I've created a couple of the trigger bindings pre-exist, ahead of the demo, so that we save the demo time for reviewing all these artifacts. And I've built a event listener as well. So you have all these bindings, trigger bindings, trigger template, and event listener, which is pre-built. And the event listener is connected to the Git. So whenever I do a Git commit on my Git repository here, it is going to generate a new image because I've pre-configured the webhooks on the Git side. So what I'm essentially going to do is go and do a quick commit on the WebView on the Vote API project itself. So this will show me a new event being generated, and that event is going to create a new pipeline within the OpenShift environment that is going to do a new deployment into OpenShift. So while we have done this deployment, we'll have to quickly switch over to the pipelines. And I've just done a commit on the Git. The commit has started a new build. So whenever developers do a commit on Git, this is going to generate a new pipeline, and all of the experience is much more automated, where you don't have to, do commits manually. It's much more seamless. The developer can solely focus on the code itself. So having discussed about the features about Tekton and the features about pipeline runs and tasks and individual steps, this is a very sample application what we've deployed. So we're going to do a quick review of a different namespace as well. We have done deployment for IBM's workloads as well. So within the IBM's workloads, IBM has introduced the Cloud Pak for integrations. Within the Cloud Pak for integrations, IBM has containerized all of its integration workloads like API Connect, Data Power, App Connect Enterprise, MQ, and event streams, and they've packaged it as a unified solution, which is the Cloud Pak for integration. So using this Tekton pipeline, what we're going to do is we'll be installing a server that will be deployed into the OpenShift runtime. So before we do that, I want to do a quick overview of what the tasks are and how the tasks are being run within this pipeline runs for Cloud Pak for integration ACE deployment. So as I mentioned, we have to create tasks as the foundational steps, right? So as the foundational steps, I've created 4 different tasks, and these 4 different tasks are building a bar file, primarily generating a bar file, and then building a bar file, and then installing the ACE server itself. So these are the key steps that are very foundational of how you get a source artifactory from from a Git source or from the, or from a developer workspace, and then building that bar file and then doing the bar file deployment into ACE runtime itself. So these are the specific tasks what we have built, and within the YAML, you'll see the underlying each task has multiple steps within it, and you'll see the individual steps within here. And we have a couple of steps that are listed out here. I'm not going to go through all of the steps, but I just wanted to give you a very high level overview of how the pipelines are and what each pipeline does. So as we've discussed about the tasks, we've created a pipeline as well. And within the pipeline, we have one single task that is going to execute all of these pipelines. And in the recent times, I've actually executed this pipeline. But what I'm going to do is I'm going to quickly go ahead and run it one more time. We can certainly run it from the Tekton dashboard itself. So I'm going to quickly switch the namespace of the new setup, which is the Cloud Pack for Integration ACE setup, and we'll do a quick install of the ACE server itself. I'm sorry. Very similarly, I'll be picking out the Git resource, the image name, the build version. I'm going to give the build version name as 2.0, and there are some specific additional features that you're not seeing in the sample app, like the environment, dev environment, and the production as false. So these attributes are listed out so that we can feed this information into the Helm parameters for Helm deployment itself. As I've mentioned before, this part of the demo is going to be done using a deployment of Helm charts. So we'll be executing Helm charts within this deployment. So I'll be quickly creating a new pipeline run, and I've given all the pipeline resource information what it's needed. We've already created this pipeline resource information previously, and this is executing the ACE install server pipeline. I'm going to quickly go over and see how the pipeline is actually running right now. So in the pipeline runs, what I can see is install ACE server pipeline is actually in progress right now, and we can certainly see some logs. Oh, looks like it is. Looks like the release name is already existing on the environment. That's the reason why it didn't entertain it. Let me just do a quick cleanup of it, and then we'll do the deployment right away. I should have cleaned it before. I apologize for that. This is the Cloud Pack for Integration, where you can see the Cloud Pack foundation layer, where all of the information is done. The deployment is done using Helm chart itself. Helm is one way of deploying your integration, your workloads into runtime environments. So what you're seeing here is you already have a pre-existing Helm release. That was the reason why it failed. So I'm just going to go ahead and quickly delete this Helm release and reinitiate the build process, right? And it is going to create a new process from there on. Let's give it a quick couple of seconds before it refreshes it. Looks like the Helm release is deleted, and we should be good to go and do the deployment again. getting back to the next steps, just want to quickly see if the deployment is apologize for this. Yeah, doing a live demo is like walking on a on a ledge. You never know what kind of things you're actually going to run into. So I've just deleted that Helm release. So it was actually deleted the Helm release. So as part of the next steps, what I'm going to do is to go ahead and deploy the initiate the pipeline again, from scratch, right? So I've recently done the pipeline, ace install run, right? We're going to create it one more time and see how it is running. And this time we'll
You
use
know
the
that
build
we
version
don't see
10
your
of
screen
2.6.
anymore.
Oh, you don't see my screen anymore?
No.
Share screen. Apologize, 1 second. How about now? Can you see my screen?
Yes, it's good now. Thank you.
All right. I apologize. I wasn't sure what happened over there. Okay. So I don't know since where I've not done the screen share or where the screen share was missed, but what happened was there was a pre-existing Helm release for the old deployment, so I had to manually go delete that out to redeploy the same implementation. So I've deleted that instance, and now I'm going to go ahead and manually create that, a new pipeline itself. So I'll be creating a pipeline run, and with this pipeline run, it should go ahead and create a new pipeline with the pipeline resources and the tasks what we've pre-configured. So quickly switching over to the pipeline runs, I want to see how the ACE is installing, and if you look at here on the logs, it is it's downloading the image from my Git repository, and it is building the image, and it's building the ACE image that it needs for the implementation. These are all part of the customized steps for the Cloud Pak for integration. It looks like the deployment is actually successful. So the installation of the ACE server was actually done. We'll go a little bit detail into the ACE server and look at the pipeline runs and look at the pipeline logs, right? We just looked at the logs. Within the same single log, towards the tail end of the implementation, what you can also see is once the image was actually being built out, there was a Helm deployment being done. And if you see the Helm deployment was actually successful. And in this Helm deployment, it is creating multiple ACE servers within the implementation. And the container image is going to be reflecting on the specific dashboard here. Or else we can quickly go ahead and see the new pod being created for that Cloud Pak for integration ACE deployment as well. Let me just do a quick switch of namespace. It's Cloud Pak for integration ACE. Also get pods. What you're seeing is it's 6 minutes ago there was this done. Sorry. OC project ACE. Let's see the pods, and looks like this is running as of right now. So at 114 seconds, there was a new pod that got created, and it is in running status as of right now. So the deployments for a sample application and the deployments for the deployments for the sample front-end and a back-end web UI applications are also done successfully from Tekton pipelines. So I assume that you have liked the demo. If you have any questions, do send it our way, and I'm happy to explain. Before I wrap the demo, I wanted to quickly go over one more slide about Prolifix, and we can call it a wrap on the webinar. So as I mentioned, my name is Sandeep Chalangi, and I head up the cloud and platform solutions team at Prolifix. Prolifix has deep expertise in cloud and DevOps as well, where we assist customers with cloud transformation journeys, helping them move towards cloud or private clouds like Red Hat, Openshift, helping them with the DevOps journey, implementing of these Kubernetes native implementations, as well as other tools like Jenkins and Ansible as well. And we also provide managed services support for all of these implementations. So if you have any questions, if you're looking for any kind of expertise, do reach out to us. And you can reach out to us at solutions@prolifix.com. And thank you for joining the session. I know it's late for some of you back in India, around the world. Thanks for joining in. Thanks for listening in.